Severn Trent Water, we're a major water and waste utility in the middle of the UK. We operate from the Midlands around Birmingham out into Wales. And a major part of our business that we're growing at the moment is renewable energy production. We have a number of sites, around about 35 across the Midlands, where we treat sewage sludge and we use it to generate electricity through the use of combined heat and power engines. Here at our site in Minworth, we've been generating for about 50 years from anaerobic digestion, where we use the digestion processes on site to generate biogas. And for many years we've fed that out into CHP engines that have allowed us to generate electricity, power the site and feed the local electricity grid. Since 2011 we've developed an alternative to this, looking at upgrading our biogas and injecting it out into the national grid in the form of gas. The site here is the first to upgrade biogas from sewage treatment works where we don't have a great control over our feedstock and what's coming into the site. So we have a number of process steps that we've put in place to treat that gas and generate the maximum efficiency. The first step, we look at removing a lot of the volatile organic compounds that we have in the gas that's coming off our digestion plant. The digestion plant is quite old, it's a standard mesophilic digester, but it produces gas that can contain anything from siloxanes, which cause problems for combustion plant if they pass out into the network, or odorants that we might find in shampoos and shower gels that could cause an impact on the gas as it flows out through the system. We remove these with an activated carbon treatment system at the front of the process so that we can get on with the real business of upgrading the biogas, as you might well see on other sites around the UK. At Minworth, we've decided to utilise a water scrubbing plant. We've done this because we've seen it operating in a number of places on the continent where we're able to see the sewage sludge, see it being upgraded at the flows and the quantities that we desire. There are a number of technologies that people can use, but because of the variability of our feedstock and the variability of the gas that we have, the water scrubber is the most resilient, and we've found it to be an excellent addition to our portfolio. We're also the first site in the UK that injected into the local transmission system. That means the national grid's slightly higher pressure system, between 15 and 20 bar gauge pressure. And what that meant was we had to introduce new compression plants onto the site and new monitoring equipment at the end. So once we've purified that gas, and we've got it to around about 97–98% methane, we then compress it and stick it out before we stick it out into the national grid. This gas is now 100% ready to go into the grid, and we have a system where we run some checks and monitor continuously the quality of that gas and the performance of that gas before we pass it under the road into the local transmission system, where National Grid take it away for use in the domestic networks at considerably higher efficiencies than we've been able to achieve before. The biomethane upgrading process has been an excellent addition to our energy portfolio, and to date we've run it for 9 months with minimal problems since commissioning, and we've injected around about 40 gigawatt hours of renewable gas. This gas is approximately enough to heat 3,000 UK homes, but what we use it for is mitigating our gas use as a company. And we now intend to be completely self-sufficient in the gas that we use to operate our business on a daily basis.